Hi guys, we're going to be talking more about graphing in chapter 5 and some shortcuts that we can take, okay? Talk about if something is linear or what we call nonlinear, okay? So linear, when you think of the word linear, what word comes to mind? Okay, and obviously I can't hear what you're saying, but line, right? So when we say something is linear, it's a straight line, okay? So here, this line is in fact linear, okay? I don't know what happened with that end there, but linear. Okay. We also want to decide if it's a function, and we have this test. Okay. It's called the vertical line test. Okay. There is a horizontal line test, but that's for something different. So if I can draw a line, a straight line through any part of the graph here, okay, and it only hits one point, it is what we call a function. Okay. So this would be a linear function because it passes the vertical line test. Okay. So you might want to write that off to the side, vertical line test. Okay, so if we look at this next one, we want to first decide, is it linear? And it's a curve, so this is what we call non-linear. Okay, and it does in fact pass the vertical line test because if I draw a line at any point, I'm only hitting the graph once, and it would be a straight line. That last one was a little rough. So this is what we call a non-linear function. Okay, and I know I didn't give you any examples of a non-function. We usually talk about it in class. So, like if we had a non-function would be if we had something like this. You can clearly see if you draw a line through it, you would have 2 points, so this would not a function. It would also be nonlinear. All linear will be functions, just FYI. Okay? All right. So that's one way to tell if something is a function is by the vertical line test, okay? And that's usually only if we're given a graph, okay? You could plot all your points if you wanted to, if you were given points. Another way is if we have a table, we want to look at the jumps. Okay, so how did we get from -2 to -1? We added 1. And then from -1 to 0, we added 1. 0 to 1 is a positive 1. And 1 to 2 is a positive 1. And then to get from 7 to 3, we're subtracting 3. And we're doing that all the way down. Now, if something changes, that's an issue. So I can see that this is 1 over -3, 1 over -3, 1 over -3, 1 over -3. They're all the same. Okay, so this would be a function. Okay, so go ahead and decide, is this one a function or not a function? Okay, so we have -2 to -1, which we're adding 1. Okay, just like before, add 1, add 1, add 1. Okay, so here we're subtracting 3, and then we subtracted 1. So right away, I can see this change was 1 to -3. This change was 1 to -1, and that's not okay. So I know right away, not a function. Oh, let me get my writing tool. Now, let's say here, okay, I had added the point 4 and -11. So this hop would have been +2, and this hop would have been -6, right? But if we look at this, 2 and 6 reduces to 1 and 3, so that's the same level. So if it reduces to the same number, that's okay. But here, 1 and -3 and 1 and -1 do not reduce to each other. That's how we know for sure it's not a function, okay? Just for your information. So if we're given ordered pairs, simply put them in a chart and then do what we did in the previous example. So if you're given ordered pairs, you can just look at the jumps between them, okay? So standard form is when we have x and y on the same side and the constants are on the other side. So if we can put something in a standard form, okay, and it's just x and just y, no weird multiplication, no weird exponents, it's linear. So this is an example of linear. It's x plus y. Let me actually get my tool out. X plus y equals a number, right? There's some numbers in front of the x and y, but that's okay. Here, I can make this one look like that, right? So I have y minus 2 equals 3x. Well, I can add the 2 over. So then I get y equals 3x plus 2. And then I could subtract the 3x over. So we have y minus 3x equals 2. So because I can put it in standard form, I know it's linear. Same thing with this problem. All I would have to do is I could add y to both sides. So I get 0 equals 5x plus y. And even though the numbers are flipped on the equals, that's totally fine. They mean the same thing. So that's why these ones are linear, is because we can put it in standard form. Nonlinear examples is like if we're multiplying x and y together. That's a no-no. That's not linear. If we have any exponents besides 1, that's linear. If we're dividing by a variable, that's linear. Okay? It doesn't matter that x and y are on the same side because we're doing other things to the x and the y. That's the problem. Okay? All right. So we're going to graph these linear functions. So they want us to put this in standard form. So I have y equals x plus 3. So in order to do that, I would have to subtract x from both sides. So I get y minus x equals 3. Okay. And then they want me to graph it as well. So I'm just going to take my x values that they gave me and plug it in. So I'd have y equals 0 plus 3, which we know is 3. Y equals 1 plus 3, which we know is 4. And y equals 2 plus 3, which is 5. Again, you might not necessarily have to write all that out, and that's fine. I'm just trying to show you where I'm getting my answer from. Now we'll plot those points. 0, 3, whoops. It does not like when I draw points. 1, 4, and 2, 5. And we would go ahead and connect those since we do have an equation showing us that line. Okay? And make sure you draw those little arrows at the end. I'm very picky about that. Okay? I hope you have a wonderful day, and we'll talk to you later. Bye.